Hello everyone, welcome to this part of the video where we are going to explore 6 examples on factorization by grouping. Okay, so I'm going to zoom in on each example now. So for the first example, again, this is Mr. Tan's style. I do like to group them into 2 groups. That's why factorization by grouping. Then from here, I try to sieve out the common factor. So let's see. So this one, I do see that the common factor is letter or the variable x. Yes, x is the common factor. And I'm left with a minus. Wait a minute. X, I've taken out x out. I'm left with, yes, 1. Why is that so? So that when I multiply back the x, I must get back my negative 1x. Okay? And at the other side, I realize there is no common factor between the variables a and 1. So what do we do in this case? A, 1, A, 1. I'm going to take out negative 1 as the common factor. And when I do that, I'm left with a minus 1. Yes. Okay, in case you are wondering why is that so, because when I expand and simplify, negative 1 times positive a, I do get back my negative a. Negative 1 times negative 1 will give me back my positive 1. And of course, last but not least, this is where we can then see that there is a common factor, a minus 1, this bracket. And that is what I will take out as a common factor. And I'm left with x and negative 1. Okay? So let's move on to the next example, B. Again, Mr. Tan going to break them out into 2 groups, and after which I'm going to be equals to, in this case, x. And when I take out the letter, the variable x, I'm left with x minus y. On the other side, I see a positive 7 as the common factor, and I'm left with y minus x in this case. Now, how do I do this then? X minus y and y minus x are 2 different brackets, variable or expression. But, I could do something such that they are the same. So I'm going to just write this down first. Instead of writing positive y minus x, this is the same as, the equivalent form of this would be negative, still got the 7, okay, x minus y. So I have to repeat, positive y minus x and negative x minus y. They are what we call equivalent terms. Alright? Because if I were to expand and simplify, negative times positive x, I do get back my negative x. Negative times negative, I do get back my positive y. So now we have done this. we would then be able to see that, hey, x minus y will then be my common factor. And I'm left with x minus 7. Okay? So for this set of examples, most of them would require us to express equivalent forms, okay, as seen in this example. So let's move on to another example. And in this case, I see a 2p minus q. I also see a minus and q minus 2p. So this example is pretty easy to do because I do see 2p minus q. If I were to put as a bracket, there's actually a 1 in front. 1 times 2p is 2p, 1 times negative q is negative q. Why does Mr. Tan do this? Because Mr. Tan is going to put a positive. Still got the m down there. But I will have a 2p minus q. Because Mr. Tan knows that positive 2p minus q and negative q minus 2p, they are equivalent terms or equivalent expressions. Okay? And once I have that, it becomes pretty straightforward already. We are going to apply what we have learned previously in this video. 2p minus q is the common factor. I'm going to take them out. And I'm left with 1 plus m. Of course, m plus 1 is also the same. They are equivalent terms as well. And we are going to have more practice on these equivalent terms. For part D, the very first thing I see across all 3 terms is that there is a common factor. Yeah? What's the common factor? 3. Yes. And therefore, I'm left with PQ minus P plus 3 minus 3Q. And then, at this point onwards, I'm going to factorize by grouping. So I would have my P as the common factor, left with Q minus, yes, brilliant, 1, very good, plus 3 bracket, yes, there is a factor of 1, 3 times 1 is 3, okay, minus Q. So this part here will be my 3, and after which, it is important at this point to see what Mr. Tan will do again. Mr. Tan saw the opportunity to rewrite this second line in an equivalent form. Negative 3 times Q minus 1. Again, for this part of the video, this is the 3rd time or even the 4th time you are seeing this. The positive 1 minus Q and negative Q minus 1. What are they called? Yes, they are called equivalent terms, which I'm going to just write it down here as well. And finally, I would then be able to factorize by taking out this Q minus 1 as the common factor. And I'm left with P minus 3. And let's move on to the next example here. And by now you should be pretty good at seeing things already, right? That the approach is always the same. I group them, and very importantly, the groups must have common factors. So in this case here, 5x. I'm left with x plus 3y. 5 times 3 is 15. X times y is xy. I'm going to take out negative 2z. And I'm left with x plus 3y. And this particular example is pretty awesome in the sense that we don't need to do or rewrite or apply the equivalent terms technique. So we can actually see that for this x plus 3y is the common factor. Take them out. And I'm left with 5x minus 2z. And the last example for this part of the video, a minus b. Oh, there is no common factor. Hey, but wait a minute. But the green color group, there is a common factor c. And when I take them out as the common factor, minus c, I take negative c as the common factor. I'm left with a minus b. Oh, this is important. Why is there a minus? Because negative c multiplied by negative b must give me back my positive bc. And it is at this point where I'm going to do this. I'm going to put this as a bracket and write down 1. 1 times a is 1a, 1 times negative b is 1b. But why does Mr. Tan do that? To allow Mr. Tan to see very visually, very clearly that a minus b could be or is the common factor. And I will have 1 minus c. And with that, we have come to the end of this part of the video. And let's continue to explore more examples on mathematics. Thank you for watching at this point in time. And if you do want to, do subscribe to my channel.